March 3rd, 1944. East Anglia, England. A damp chill hung in the air as Lieutenant William Overstreet sat at his small wooden desk in the officers' quarters at Debden Airfield, pencil in hand, writing a letter to his sweetheart back in Virginia. His fingers trembled, not from fear, but from the bone-deep fatigue that came after weeks of dawn patrols, debriefings, and the constant tension of knowing that any mission could be his last. "Tomorrow, we're doing something everyone said was impossible," he wrote, "flying all the way to Berlin and back in a single-seat fighter. The brass kept telling us it couldn't be done." Through the rain-streaked window, he could see ground crews moving under the harsh glare of floodlights, their silhouettes bent over the sleek lines of his P-51B Mustang. They were attaching two strange cylindrical objects beneath the wings, long, tapered tanks wrapped in coarse brown paper, looking for all the world like oversized parcels from a department store. Some of the pilots had taken to calling them paper bags, half in jest, half in skepticism. When Overstreet had questioned their reliability earlier that evening, the crew chief, a grizzled veteran named Sergeant Tom Riley, had chuckled. "They're made of laminated paper and plastic resin, Lieutenant. Same stuff the Brits have been using on their Spitfires. They'll hold fuel long enough to get you there and back. Don't worry. They've been pressure tested, leak checked, and signed off by the boffins at Bovington." What neither man fully appreciated in that quiet moment was that these unassuming containers, crafted not in a defense contractor's factory, but in a converted newspaper plant by workers who normally set type for the London Times, were about to solve one of the most critical problems of the European air war. The mathematics of aerial combat had long been governed by range, fuel, and time over target. Now, through an innovation so humble it defied military orthodoxy, the Allies were about to tip the balance decisively in their favor. Victory would not come from a new engine or a heavier gun, but from compressed paper soaked in synthetic resin, a solution born of necessity, refined by collaboration, and deployed at scale with ruthless efficiency. The crisis had reached its breaking point on October 14, 1943, a day that would forever be known as Black Thursday. At Halesworth Airfield, Colonel Hubert Hub Zemke, commander of the 56th Fighter Group, stood before the large operations board in the briefing room, watching as mission reports trickled in like casualty lists from the trenches of the Somme. Of the 291 B-17 Flying Fortresses dispatched to strike the ball-bearing factories at Schweinfurt, 60 had been shot down by German fighters and flak. Another 17 were so badly damaged they had to be scrapped upon return. In total, 77 aircraft were lost, a staggering 26.5% of the attacking force. 600 airmen were dead, wounded, or missing. The strategic bombing campaign, the cornerstone of American air doctrine, was hemorrhaging men and machines at an unsustainable rate. Without fighter escort beyond the range of existing aircraft, the bomber streams were vulnerable for hours over the heart of Germany. Technical Sergeant Robert Morgan, ball turret gunner aboard the B-17 Memphis Belle's sister ship in the 100th Bomb Group, gave stark testimony to intelligence officers upon his return to Thorpe Abbotts. "The Jerrys waited until our thunderbolts turned back at Aachen, that invisible line about 375 miles out. Then they came at us in waves, head-on attacks from FW-190s, rockets from Ju-88s sitting just outside our 50 caliber range. We were sitting ducks for 3 hours. I counted 12 separate fighter passes. We lost 3 ships in the first 10 minutes. The problem was brutally simple, rooted in physics and logistics. The P-47 Thunderbolt, powered by the mighty Pratt & Whitney R2800 engine, was a superb high-altitude fighter, but its combat radius with standard 150-gallon metal drop tanks was only 375 miles. German fighter commanders, led by General Adolf Galland, had quickly learned this limitation. They established fighter boxes beyond the escort range, where formations of Bf-109s and Fw-190s would wait in ambush, attacking with coordinated, methodical precision. The result was a slaughter. In a modest office at the 8th Air Force Technical Section in Bovington, Colonel Cass Huff, an aeronautical engineer with a quiet demeanor and a mind for practical solutions, was examining a prototype that looked more like a school science project than a weapon of war. It was a 108-gallon auxiliary fuel tank, constructed not of aluminum, but of multiple layers of craft paper impregnated with resorcinol formaldehyde resin. The design had originated not in the US, but in Britain, where metal shortages had forced engineers to innovate. Huff had spent the better part of 1943 refining this concept in collaboration with British engineers, including Colonel Bob Schaefer of the RAF's Air Ministry. The British had been driven by desperation, with aluminum allocated almost exclusively to aircraft production. Every pound of metal was precious. But hug. The paper tank weighed 50 pounds when empty, compared to 150 pounds for its metal equivalent. That 100-pound reduction per tank, 200 pounds total for a P-51, translated directly into increased fuel capacity, extended range, and improved aircraft performance. Every pound saved meant another gallon of 100-octane aviation fuel could be carried, another mile flown, another minute of combat endurance. The engineering was deceptively sophisticated. The tank was constructed in 3 main sections: a nose cone, a tail cone, and a cylindrical body. The center section consisted of 12 to 16 layers of craft paper, wrapped around a wooden mandrel and bonded with resorcinol glue, a waterproof adhesive developed in the 1930s for marine applications. Internal wooden anti-slosh baffles, shaped like petals, called gores, prevented fuel from surging during high-G maneuvers. The entire assembly was then coated with fire-resistant lacquer and finished with a thin layer of aluminum paint to reduce solar heating and provide a degree of radar signature reduction. Each tank underwent rigorous testing, pressure tested to 6 psi, subjected to vibration tables simulating flight conditions, and exposed to temperature extremes from minus 60 degrees Fahrenheit to plus 120 degrees Fahrenheit. They were designed to function flawlessly from sea level to 40,000 feet and to withstand 3 Gs of acceleration when full, 9 Gs when empty. Most critically, the fuel feed system integrated seamlessly with the aircraft's existing plumbing, using check valves to prevent fuel loss when the tanks were jettisoned. The first combat test came in February 1944, when P-47s of the 56th Fighter Group flew a mission to Hanover, using British-made 108-gallon paper tanks. Major James Goodson, leading the flight, reported in his after-action summary, "Tanks performed flawlessly throughout the 1,100-mile round trip. No leaks, no structural failures, no fuel transfer issues. Range extended by 125 miles over metal tanks due to weight savings alone." But the true revolution began with the arrival of the P-51B Mustang at Debden in late February 1944. Colonel Donald Blakesley's 4th Fighter Group, the legendary Debden Eagles, composed of former Eagle Squadron pilots who had flown with the RAF before Pearl Harbor, received their first Mustangs on February 28. The transition was abrupt. Pilots had less than 24 hours to convert from the heavy radial engine Thunderbolt to the sleek, Liquid-cooled Mustang. Captain Don Gentile, who would finish the war as one of America's top aces with 30 victories, logged only 45 minutes of flight time in the P-51 before his first combat mission. Yet it was the marriage of the Mustang's exceptional aerodynamics and the paper drop tank's extended range that changed the course of the air war. With two 108-gallon paper tanks, the P-51B's combat radius extended to 850 miles. Berlin, 580 miles from East Anglia, was suddenly within reach. The morning briefing on March 4, 1944, was electric with tension. At Debden, Intelligence Officer Major John McCulpin stood before a large map of Europe. He pulled back a curtain to reveal a red ribbon stretching from their base all the way to the heart of the Third Reich. "Gentlemen," he said, his voice steady, "for the first time in history, single-engine fighters will escort bombers to Berlin and back. This 1,100-mile round trip marks a historic milestone that will fundamentally alter the strategy bombing campaign." Captain William O'Brien of the 357th Fighter Group, present that day, recalled decades later in an Air Force Historical Division interview. "You could hear a pin drop. Then someone let out a low whistle. Berlin. We all knew what it meant. We were going all the way to the Nazi capital in fighters, something the brass had sworn was impossible just months before. Ground crews had been working since 0300 hours, carefully unwrapping the paper tanks from their shipping crates and mounting them on the Mustang's underwing pylons. They had to move quickly. The resorcinol resin would begin to degrade after 5 hours of exposure to aviation fuel, causing micro-leaks that could compromise the mission. But 5 hours was enough for the round trip to Berlin and back. Colonel Blakesley's pre-mission briefing to his pilots was recorded by intelligence officer Captain John Slater. "These paper tanks will get you there and back. When you hit the initial point over the Targe, punch them off and engage any enemy fighters. Remember, with these tanks, we own the sky all the way to Berlin. No more turning back at Aachen. No more leaving the bombers alone." The mission was not without cost. The 4th Fighter Group lost Lieutenant Alan Bonte, shot down by flak near Brandenburg during the egress. But the psychological impact on both sides was profound. Luftwaffe pilot Oberleutnant Heinz Knock of Jagdgeschwader 11 wrote in his diary that night, "American fighters over Berlin. Our intelligence had insisted this was logistically impossible. Everything we had been told about Allied fighter range was wrong. If they can reach Berlin, nowhere is safe." For bomber crews, the sight was transformative. Ball turret gunner Sergeant Dale Rice of the 100th Bomb Group later testified in official debriefings, "We were approaching the initial point when I saw them, P-51s at 30,000 feet, contrails streaming behind them like silver ribbons. One waggled its wings as it passed over our formation. I could clearly see the brown paper tanks under its wings. In that moment, I knew we'd make it home. The fear that had gripped us since Schweinfurt just lifted." The strategic impact was immediate and measurable. On March 6th, when over 700 heavy bombers returned to Berlin with Mustang escort, Luftwaffe interceptions decreased by over 60%. Major Walter Nowotny, one of Germany's most decorated aces with 258 confirmed victories, filed an urgent report to Luftwaffe High Command. "The Americans have solved the range problem. Their fighters are now operating over all of central Germany with impunity. Our tactical advantage of waiting beyond escort range is gone. We must rethink our entire defensive strategy." The numbers told the story. Before the introduction of effective long-range escort in late 1943, the 8th Air Force's monthly bomber loss rate averaged 7.6%, with catastrophic peaks like Black Thursday's 20.6%. Once P-51s equipped with paper drop tanks began regular deep penetration missions in March 1944, the average loss rate plummeted to between 1.5% and 2.2%. This dramatic reduction saved an estimated 8,000 bomber crew lives over the next 15 months and made the strategic bombing campaign sustainable for the first time. The production chain for these tanks exemplified the best of Allied industrial cooperation and innovation. Oater Lloyd, a London-based paper company that had produced 60% of Britain's newsprint before the war, converted portions of its massive facilities in Sittingbourne and Kemsley, Kent, to tank production. The company's expertise in paper lamination, combined with access to raw materials like recycled newsprint and packaging paper, made it ideal for the task. A resin, resorcinol formaldehyde, was produced by Imperial Chemical Industries, ICI, using phenol and formaldehyde, materials that did not compete with other war priorities like aircraft aluminum or rubber. The entire production process, from raw paper to finished pressure-tested tank, took approximately 72 hours. Workers, 70% of them women who had previously operated printing presses or folded newspapers, worked 3 8-hour shifts to meet the surging demand. By May 1944, Bowater Lloyd alone was producing over 1,000 tanks per week, supplemented by smaller facilities and even distributed home workshops across southern England, where skilled laborers assembled components in their garages and spare rooms. Logistics were equally ingenious. The tanks were shipped, flattened, and wrapped in heavy brown paper, allowing a single C-47 Skytrain to carry hundreds of units, compared to just 40 metal tanks. This efficiency proved crucial after D-Day, when forward airfields in France and Belgium were supplied primarily by air. Master Sergeant Donald Manor of the 357th Fighter Group kept meticulous records, showing that his team could equip an entire squadron of 48 Mustangs with fresh paper tanks in under 3 hours on mission days. The system had one critical limitation. The resin would slowly dissolve due to the solvent effects of 100-octane fuel, causing leaks after 5 to 6 hours. This made the tanks strictly single-use items. Ta-ta for now. Filled only in the final hours before takeoff. Yet this very disposability became a strategic advantage. Unlike metal tanks, which littered European fields for decades, killing livestock and damaging farm equipment, paper tanks were partially biodegradable. They dissolved in rain within months, leaving only small metal fittings, filler caps, mounting lugs that could be collected and sold for scrap. French agricultural reports from 1946 confirmed no lasting soil contamination from paper tank debris, while areas strewn with metal tanks required cleanup well into the 1950s. German attempts to replicate the technology failed, not for lack of technical understanding, but due to systemic weaknesses in their war economy. A captured technical intelligence report from Messerschmitt AG dated May 15, 1944, acknowledged, "The enemy is using disposable fuel tanks of revolutionary construction, made from laminated paper and phenolic resin. We have attempted to duplicate this technology but lack the industrial infrastructure for mass production." The reasons were manifold. Germany's paper mills had been converted to producing military maps, documentation, and currency, leaving little capacity for non-essential paper goods. The phenolic resins were prioritized for aircraft interior components and electrical insulation. Most critically, Germany lacked the decentralized, resilient manufacturing model that made Allied production so robust. Their industry was centralized, vulnerable to bombing, and rigidly hierarchical, incapable of the rapid adaptation and distributed innovation that characterized the British-American effort. Luftwaffe leadership understood the implications immediately. In post-war interrogations conducted by the U.S. Strategic Bombing Survey, senior officers confirmed that the appearance of Mustangs over Berlin shattered their defensive doctrine. While the famous quote attributed to Hermann Göring, "When I saw Mustangs over Berlin, I knew the war was lost," cannot be verified in primary German records, documented testimony shows he stated in a May 1944 conference, "Long-range Allied fighters have delivered a major strategic blow to our planning. When their fighters appear over Berlin, the results will be, in my words, tragic for Germany." General Adolf Galland, inspector of fighters, was more direct in his 1945 debriefing. American fighters ranging over all of Germany with impunity effectively broke the Luftwaffe's defensive strategy. We could no longer concentrate our forces for decisive engagements. We were forced into a war of attrition we could not win. The tactical advantages extended far beyond bomber escort. With extended range, Mustangs conducted fighter sweeps deep into Germany, attacking Luftwaffe airfields, rail marshalling yards, and V-1 launch sites. Colonel Hubert Zemke's tactical analysis in May 1944 concluded, "The extended range provided by British paper tanks has fundamentally altered the air war, allowing us to seize the initiative completely. We are no longer reacting. We are dictating the terms of engagement." Pilots confirmed the performance in combat reports. Lieutenant Colonel John Meyer, who would finish the war with 24 aerial victories, flew the March 6 Berlin mission. His National Archives preserved report noted, "Took off at 10:45 with 208-gallon paper drop tanks. Experienced perfect fuel transfer throughout the flight. Released tanks at 13:47 near Wittenberg when bounced by FW-190s. Engaged immediately after release. The weight difference dramatically improved roll rate and climb. Shot down one FW-190, damaged another, returned to base with 45 gallons remaining in internal tanks. Without those paper tanks, we would have turned back at Brunswick, 200 miles short of Berlin." Technical analysis by Republic aviation engineers revealed unexpected benefits. Paper tanks had superior aerodynamics to metal tanks, creating less drag due to smoother surface finish and more efficient shaping. They were also less likely to explode when hit by enemy fire. The paper and resin construction would tear rather than fragment, reducing the risk of catastrophic fuel ignition. Colonel Francis Gaby Gabreski, the European theater's leading ace with 28 victories, flew his most successful mission on July 5, 1944, using paper tanks to reach Brandenburg, drop them when engaged, and shoot down 3 Bf-109s in a single pass. His after-action report noted perfect tank performance at 30,000 feet despite -40 degrees Fahrenheit temperatures, clean release when bounced by enemy fighters, and critical improvement in climb rate after release. By September 1944, the Luftwaffe's day fighter force was effectively broken. Galland reported to Hitler, "American fighters are ranging over all of Germany with impunity. Our pilot training program is collapsing. New pilots have fewer than 50 flight hours. The Americans have 400 plus. We are losing experienced leaders faster than we can replace them." The paper tanks proved vital during the Battle of the Bulge in December 1944. With forward airfields hastily constructed and ground supply lines stretched to the breaking point, the lightweight, compact paper tanks could be delivered by light aircraft or even parachute drop. Captain Jack Ilfrey, commanding the 20th Fighter Group, documented surge operations during the bulge. We flew 3 missions on December 23rd, each time with fresh paper tanks. Ground crews were able to rearm, refuel, and mount new tanks in 20 minutes. Without that flexibility, we couldn't have maintained air superiority over the battlefield. Even in the war's final days, the system demonstrated remarkable adaptability. On March 24, 1945, during Operation Varsity, the airborne crossing of the Rhine, Lieutenant Robert Powell of the 55th Fighter Group took off at 0600 with 2 108-gallon paper tanks, flew to the Rhine, dropped them when engaged by Me-262 jets near Frankfurt, fought for 15 minutes, landed at a forward strip in Germany, took on new tanks and fuel, and flew a second combat mission the same day, a feat impossible with heavier, less logistically flexible metal tanks. The human dimension of this story extended to the thousands who built the tanks in anonymity. At the Sittingbourne facility, production workers, many of them mothers, daughters, and wives of servicemen, knew that every tank they built meant an American or British airman might return home to his family. Quality control was relentless. Each tank was individually inspected, pressure tested, and signed off by a senior technician. The specifications achieved were remarkable for such a seemingly simple device. 108-gallon capacity, 110 total, 108 usable, 100 inches in length, seamless fuel transfer at all altitudes, and reliable jettison under combat conditions. Post-war analysis by the Pentagon confirmed the strategic payoff. The 79% increase in fighter range from 475 miles with internal fuel to 850 miles with paper drop tanks brought every industrial target in Germany within escort capability. General James Doolittle, commander of the 8th Air Force, wrote in his final report, "The extension of fighter range through auxiliary fuel tanks, particularly the British-manufactured paper tanks, was the single most important tactical development of the air war in Europe. It transformed the P-51 from a good fighter into a war-winning weapon system." Lieutenant General William Kepner, commander of 8th Fighter Command, summarized the impact in 1946 congressional testimony. "The paper drop tank gave us air superiority over Europe. Without it, our bombers would have continued to suffer prohibitive losses. Without it, our fighters couldn't have hunted the Luftwaffe to extinction. Without it, D-Day might have failed." The legacy of the paper drop tank endured far beyond 1945. The lamination techniques developed at Bowater Lloyd influenced civilian aircraft interior panels, aerospace composites, and even the early printed circuit boards of the electronics revolution. Workers trained in precision paper construction founded companies producing everything from television cabinets in the 1950s to architectural laminates in the 1960s. At the 1995 50th anniversary reunion of Allied fighter groups at Duxford Airfield, former Luftwaffe General Adolf Galland was invited to speak. When asked by a young historian what single factor turned the tide of the air war, the old ace paused, then pointed to a displayed paper drop tank in a museum case. "This simple thing," he said, "meant we could never be safe, never rest, never rebuild. It brought the air war to our doorsteps every day until we had nothing left to fly. The Americans didn't just build better planes. They solved the logistics problem we couldn't even see." On March 4, 1944, when Lieutenant William Overstreet flew over Berlin with paper tanks under his wings, he carried more than fuel. He carried the culmination of months of quiet innovation by engineers, chemists, and factory workers who would never wear a uniform. but whose contribution proved as vital as any dogfight or bombing run. The paper drop tank story stands as testament to a fundamental truth of modern warfare. Victory often depends not on revolutionary technology, but on the innovative application of simple, achievable solutions at massive scale. A British paper company, an American fighter, compressed paper soaked in resin. Together, they gave the bombers safe passage to Berlin and brought their crews home.